All right, so we're going to talk about functions today and tomorrow. And I think on Wednesday, maybe, if Wednesday we have a class. I don't think we have a class on Wednesday, but at least for today and tomorrow, we'll talk about functions in C and in MIPS. So when you write functions in C, we've actually done that very briefly. So let's start with main. And let's create another function here that says, for example, void. Yeah, let's start with something like void. And let's say random function. And let's say this function is gonna say int some variable, maybe another variable. And I'm gonna do the same thing here. Let's say, var1 equals to 100, int var2 equals to 200. So what you need to do, or rather what you need to know about converting C code to MIPS is that it happens one function at a time. It happens one function at a time, meaning that what you can do is I can convert this one to MIPS, and I can convert this one to MIPS, and I can just combine the MIPS together and it'll work. In fact, you can convert this one to MIPS, and I can convert this one to MIPS, and we don't have to talk. You and I don't have to talk. We don't have to make any, we don't have to say, okay, I'm going to use the S0 and you use S1. We're going to follow some kind of rules. And if you follow those rules that I'm going to follow, then you can write code here, to translate this C code to MIPS, and I'll be writing code here to translate this C code to MIPS, and we can just combine the two MIPS pieces of code, and it should work. So, and this is really what we're going to talk about, but we're going to start with some of the challenges. For example, let's say I'm going to call my random function here. Let's say, for example, so this one, let's say someone is going to convert that one to MIPS. Let's say Anthony is going to say, I'll take care of this one. You don't have to worry about this one. I'll do it. And what Anthony goes and does is that, he goes and says, okay, for this one, I'm going to use S0. So maybe add immediate is 0, 0, 10. And for this one, I'm going to use S1, add immediate S1, 0, 20. And that's okay. That's what Anthony gives me. And for me, maybe I'm going to say, let me use S0 for this one, S1, because I haven't spoken to Anthony yet. So I'm going to say, okay, add immediate S0, 0, 100. And that's going to be for var1. And then I'm going to write some code to call Anthony's code, which I haven't I haven't shown you yet, which is okay. And then I'm going to say add immediate S1, 0, 200. So clearly there's a problem here. And let me tell you where the problem is in case you haven't seen it, you don't see it. So this part is going to put 100 in S0. And then I'm going to call the function that Anthony wrote, which is here. Again, I'm not going to show you how that's going to take place, but essentially when you call a function, you go and execute the code there. And what's happening here, and let me actually change this one to maybe var1 plus 200. So that would be add immediate S0, 200. So when I get to here, I'm going to change S0. I'm going to change S0 because Anthony decided to use S0 for M. Do you see the problem here? The problem here is that by the time I'm done with this, and when I get back to my code that actually called the function, when I add 200 to S0, that's not going to add 300. That's not going to give me 300. Now, of course, in code, this should give me 300, right? I mean, if you write this code plus this code, and if you run it, of course, you expect var2 to have 300. That's what you want it to have. But if the translation to MIPS was like this, which is what you're seeing, then we have a problem. Because var2 is not going to be 300. var2 is going to be 210. Because this random function changed s0. And when I'm adding s0 to 200, I'm going to end up at 210. And there's, of course, only one s0 and one s1 and one s2. These are registers, hardware pieces that you can't just clone like variables where you say, I want to create another s0 or s1. You can't do that because these are hardware pieces. So this is a problem. This is a big problem, and we need to kind of resolve it. But before I talk about the resolution, do you have any questions about what I'm showing you here? Do you see the problem? Okay. So let's talk about, before we kind of talk about this, the solution to this problem, let me give you code that's going to actually call this function. So when you have functions like this in C, and when you want to translate that to MIPS, you actually start with the function name, and that's going to be the label. So again, we're going to have .data, which is going to be empty in this case because we don't have any global variables. Then there's .text, which contains the code. And what we're going to start doing, starting today, is we're going to start with the function name. So there's going to be main, which is really at the beginning, and there's going to be random function. And what's going to happen here is, of course, we're going to do the main code, which is this. And here, for me to go to the function, I can do jump random function. That's going to essentially take me to here. And of course, in my random function, I need to add the code that, again, I'm going to start with. Again, this code has a problem because it'll change s0, and that's going to change the s0 here. But that's okay for now. And when I'm done with this function, I'd like to jump back to here. So the way we do that is using something called jump and link. So there is this instruction called jump and link. It's a MIPS instruction, of course, jump and link. So this is jump and link. And this one does actually two things. One of them is it puts the address of the following instruction in a register. It's one of the special purpose registers in a general purpose register. In a general purpose register called RA. So this is the first step, and I'll talk about that more after I finish writing this. And the second one, it jumps to the label. So the syntax is jump and link, and there's a label here. So this is the syntax, which is kind of identical to what you're seeing here. There's a jump and link, and there's random function. So again, what's going to happen is the address of this instruction. So there's going to be an instruction here, and we can actually put that instruction because we wrote it. That's going to be this one. The address of this instruction, the address in the RAM to this instruction, is going to be placed in this register called RA. And then we're going to, when we execute this one, we're going to jump to here, and we're going to do this one. We're going to do this one. Of course, we don't need semicolon here for the MIPS. And then once we're done, we need to go back to here. And because we're putting the address of this instruction in this register called RA, I can use RA to go back to the caller. So I can do that by doing jump register RA. So that's another instruction. So right now we're talking about two new instructions. One of them is called jump and link. This is new. This is similar to jump. I mean, you've seen jump. This jump and link, the difference between this one and jump is that it has this step, which is whatever address of the following instruction is, I'm going to put it in RA. That's what it does. And then, of course, we jump, just like the jump. The other instruction is called jump register. Jump register. And essentially what it does is it jumps to the address in the register that's specified. So the syntax of this one is jump register, and here there's a register. So here at the end of my function, I can say jump register RA, and because I know this guy is using jump and link, because that's how we call functions, I know that RA is going to contain the correct value, and we're going to go back to here. And then I'm going to continue. Now, of course, if I don't do anything here, there's going to be a problem, because as soon as I'm done with this, I'm going to continue going sequentially. I'm going to do this, and jump register is going to take me back to here, because that's what's in the return address, register RA, and that's going to be essentially an infinite loop. So I don't want that. So the way I kind of halt the program is there's something called syscall, which essentially transfers the control back to the operating system. But before I do that, I need to put a value in V0 that indicates that I need to quit the program. So I can do 10 in V0 like that. So I'm putting 10 in V0, and I'm doing syscall, which will transfer the control back to the operating system. Now, the operating system is going to look at the value of V0, and depending on the value, it'll do something. So if the value is 10, then that's going to be exit the program. That's what it means. So this is what it means. And this is just something that you're going to have to essentially remember. So if you Google the syscall codes, you will see a bunch of them, and each one does something. For example, if you put the value 1 in V0 and do a syscall, what's going to happen is the operating system is going to print a value, and this value is going to be whatever is in A0. That's how it works. So let me open the simulator actually, and let's do some fun exercises here. But at the beginning, I'm just going to do what I said I would do, which is putting 10 in V0 and doing the syscall just to make sure that, we actually, in fact, I can just copy all of that and put it in the simulator. And what's interesting here, can I do this? Yeah. So what's interesting here is I'm going to actually start with none of that. So I'm going to comment all of that, or let me just delete all of it. And let me show you something that you might find interesting. If I say add immediate, let me expand this. And let's say S0010. If I hit a symbol, then play, it's going to run, and it'll run perfectly fine. So if you look at S0, here's S0, you'll see that it has 10. But what you'll notice is that it says program is finished running, and then it says dropped off bottom. So this dropped off bottom means that it just continued going, like it just continued going line by line until there were no more lines, essentially. That's what it means when it says dropped off bottom. However, if you want to really end it gracefully and correctly, you would have to put 10 in V0 and do syscall. That's a proper way of doing it. So you can say add immediate V0 0, 10. So let's change that to 50 so that we're not confused here. And then I'm going to do syscall. Now, if I hit play here, you can see that it says program is finished running. It doesn't say this. What you're seeing here is from the previous one. This is really what it's saying. So this is really the proper way of doing it. Would be to put 10 in V0 and do the syscall. So let me take this one. Again, this one has a flaw. This code has a flaw, but that's okay. I'm going to just assume that we're all that we're just new, and that's what we are actually. I mean, when it comes to writing functions, we are all kind of new. Not me, but you. This thing is really, I'm really not happy with this. I wish they should fix this in the simulator. Yeah, this is actually rather annoying. Okay. For now, I'm gonna just leave it like this because, okay, that's fine. At least we can, yeah, at least we can kind of do this and it'll show the whole thing, which is okay for now. Okay. All right. So let's see. Let me actually also copy the C code because I can give you this as, so we don't need a dot data. Let's just save one line. And of course, we want to comment that. And then I'm going to take this one. Okay. So let's look at both functions again. Let me do that, maximize like this. So random function is going to put 10 in M, 20 in N. And here I'm using S0 for M and S1 for N. That's just what I decided. And then for main, I'm going to put 100 in var1, which is really this. And then I'm going to call the function. So I'm going to say jump and link to here. And again, jump and link is going to put the address of this instruction in the return address register, which is here. Do you see this, RA? Can you see this, or is this too small? Can you see RA here? Yeah, so that's good. So this is the return address. That's what's going to happen when you call jump and link. The address of this instruction is going to be stored in return address. And then I'm going to jump to here. I'm going to do these two, jump register RA. And because this is what's stored in return address, I'm going to get back to here. I'm going to put, I'm going to add 200 to S0. And then I'm going to put it in S1. And then I'm going to put 10 in V0 and syscall. Let me see, there's a comment here. Shouldn't the third line in main be, the third line in main should be S1, 0. No, I mean, right now you want this to be 0. But here we have var1 plus 200. I think yeah, it was, you're right. At the beginning it was like that, but then we decided to change it because I need to show you that there's going to be a mistake here. So I want to use S0 again. Okay. So again, if you write this in C and if you run it, you expect var2 to be 300. Are we in agreement that this is what we should expect? We expect var2 to be 300. That's good. That's what we should expect. However, based on this implementation or based on this conversion, it's not going to be 300. It'll be 210. The reason why it'll be 210 is because for that random function, we decided to use S0 to be 10, which is a mistake. This is a mistake because we're not following the rules that I haven't shared with you yet. But I'm going to run this anyway, just to show you jump handling, show you jump register, and then we can stop the recording and we can, once we stop the recording, we can either talk about syscall or we can talk about the problem, how to solve this problem. And I think we should talk about how to solve this problem before talking about printing integers and floats. I mean, this is going to be fun and easy part, but I would say let's delay this. I think it's more, finding a solution to this is more pressing. Okay, I'm gonna assemble and I'm gonna go line by line. So the first line, of course, is gonna put 100 in a 0. This line is gonna jump to where? To here. And you can see after I go one line, you will see the highlighted line is gonna become this one. In addition to that, the return address is going to contain the address of this one. Now, if you look at this leftmost column, you see the address of that instruction. This is really the address in the RAM. This should be the address in the RAM. So the value of return address is actually going to be the address of this one, which is 004000008. Of course, the problem is this is in hexadecimal, this is in decimal, so we need to make a minor change here. Let's say, let's display, those values in hexadecimal. That'll make it easier for us to look at this one, which is 004000008, and compare it with RA once we, of course, execute this line. So I'm going to execute this line. I'm going to go just one click. I'm just going to click it once. Okay, look at the yellow highlighted line. Just pay attention, see what's going to happen. Okay, did you see what's happened? The highlighted line became this one. So we actually jumped. Usually we go sequentially. Of course, in a branch on equal and branch on not equal, sometimes we jump, but here we don't have any branches. Jump and link is going to branch. It's going to jump. And it's going to jump to here because this is really this line, which is the line after the label. Now, if you look at return address, it's also highlighted in green. And you can see if you look at the value here for 0000008, or rather for 00008, so only 4 zeros. And you just look at the address of this instruction, you will see that it's the same. Does that make sense? Give me a thumbs up if that makes sense. So jump and link, it's going to put something in the return address, then it's going to jump. So it really links and jumps. I mean, doesn't really matter. I mean, maybe they happen at the same time, but it'll really kind of put the value before it jumps, or maybe right at the same time, at jumping, but not after. Because once we're jumping, we may have lost the address of this one. Anywho, let's continue. I'm going to go to the next line. You can see that this one's fine. I'm going to go to the next line. This one is fine. So I have 10 in S0 and 20 in S1. All of this is fine. And of course, jump register RA is going to jump me back. It's going to take us back to this one. So I'm going to go one line and you can see we're actually here as expected. And now S0 is going to be the value 10. If you look at S0 here, you will see it has the value A, which is 10. And of course, if you add 200 to it, you end up with 210, which of course I can show you if we go back to decimal, it'll be easy. You can see 210. So this is bad. We don't want 210. We wanted 300, but we ended up with 210. And of course, when you put 10 in V0 and when you syscall, the program ends. You can see that I cannot press on this button anymore. So this is good. We were able to, write our first, functions in MIPS. It has a flaw which we have to fix, but we're close. We learned about syscall. We learned about putting 10 in v0 before doing syscall, which will mean, in the program. We learned about jump and link, which is going to put the address of the next instruction in the return address register, then it'll jump to that label. We learned about jump register, which will use the value of this register, which could be anything. Of course, for now, it makes sense to put RA, but really you can put any register here. And then that's going to take us, of course, back to the here. And we're going to go sequentially up until this point. Yeah, which, as I said, will end the program. So do you have any questions before we stop the recording and start talking about finding a solution to this problem? Okay, so it seems that no one has any questions. I'm gonna stop the recording.